All right, so let's dive into some seriously practical Terraform knowledge today. You send over a bunch of real-world interview
Mhm.
questions that you've come across, and honestly, they're
Yeah.
spot on. This is stuff every Terraform user
Yeah.
needs to know.
hmm
Think of it like a cheat sheet to go from just using Terraform
Right.
to really understanding those nuances.
I'm all about that, getting past that surface level into those aha moments where it clicks.
Exactly. And we've got some juicy topics lined up.
Yeah.
Debugging without losing your sanity,
Mm-hmm.
the surprising power of null resources,
Right.
which honestly sound way more boring than they actually are,
Yeah.
and why formatting your code is about way more than just being tidy.
All essential stuff. We've got some great examples to make it all really clear.
Okay, first up, building blocks.
Yeah.
We've got count and for each,
Right.
both used for creating multiple resources,
Mm.
but they're definitely not interchangeable. I'm betting you've got a way to make this crystal clear for our listener.
Absolutely. So let's say you are setting up a cluster of, say, 5 identical web servers.
Way.
Count is your go-to
Okay.
because you know the exact number that you need up front.
Gotcha.
It's like using a cookie cutter.
Okay.
Each server has the same configuration.
So kind of like an assembly line for servers.
Exactly.
Okay.
But what if you need to spin up virtual machines for different departments, each with their own specific settings? That's when for each shines.
Okay.
You give it a list or map of departments and their specs,
Okay.
and it creates each VM with the right configuration.
Oh.
Think of it as a more personalized approach.
So it's like having a tailor-made suit versus buying off the rack.
There you go.
Makes total sense.
Okay.
Now, let's be honest. Even the best of us stare at error messages sometimes, wondering what on earth went wrong.
Oh, it happens to everyone.
Oh, yeah.
And that's why having a solid debugging strategy is key. The first thing I always recommend is turning up the volume on Terraform's logging. Setting the tflog environment variable is like giving Terraform a megaphone. It starts shouting out what it's doing
Okay.
at each step.
So it's like getting a behind-the-scenes peek at Terraform's thought process.
Exactly.
Okay.
If you need even more detail, redirect those logs to a file.
Okay.
It's like having a transcript you can go back and analyze,
Mhm.
piecing together the clues.
And speaking of clues, what about the Terraform validate command?
Oh, yeah.
I always use it, but honestly, I'm not always sure what it's actually doing.
Think of it as a spell check
Okay.
for your Terraform codes.
Okay.
It catches those little syntax errors, a missing bracket here,
Uh-huh.
a misspelled variable there,
Right.
before they can cause any real damage.
Oh, I see. It's like that moment when your word processor catches a typo before you send an important email.
Exactly.
Definitely saves you from some awkward situations. So we've got our code validated. Now it's showtime.
Not quite yet.
Huh.
Remember the dress rehearsal?
Okay.
That's where Terraform Plan comes in. It shows you exactly what changes Terraform is going to make to your infrastructure,
Okay.
giving you that last chance to spot any potential disasters before they happen.
Right.
Trust me, reviewing the plan carefully is much less painful than trying to clean up a mess afterwards.
Totally. I once skipped reviewing the plan thinking I was in a rush and ended up accidentally deleting a production database. Lesson learned.
Mm.
Always review the plan.
I've been there. We all have those moments.
Okay, let's say we're ready to roll. I've got my code, it's validated, and the plan looks good.
Okay.
But now I'm wondering, where does all the action actually happen? Is it on my machine or somewhere else?
That's a great question. It all depends on whether you're using local exec or remote exec provisioners.
Okay.
Local exec is all about running commands on your own machine. Imagine you're setting up a website and you need to generate an SSL certificate using a script on your computer. Local exec lets you do that within your Terraform code.
Okay, so it's like using Terraform to orchestrate things happening directly on my machine.
Exactly.
Okay, what about remote execs then? That sounds intriguing.
Remote execs is where things get really powerful. Let's say you've just provisioned a brand new web server out in the cloud. Now you need to configure it, install software, tweak settings, get it ready for action.
Right.
Remote execs lets you run commands directly on that server,
Okay.
all as part of your Terraform workflow.
So it's like having a remote control for my cloud resources.
Exactly.
But I can imagine that comes with some security concerns.
You're right to be cautious. Remote execs gives you a lot of power, so it's critical to use it wisely. Think carefully about what commands you're running, where those commands are coming from, and what access they have.
Okay, I'm starting to see why this topic pops up in interviews.
Right.
It's not just about knowing the commands, it's about understanding the implications.
Exactly. It's about thinking like an engineer, not just a code monkey.
Now get ready for this one. We're about to talk about something called the null resource.
Uh,
Honestly, when I first heard the name, I thought it was some kind of placeholder,
yeah.
like a resource that does absolutely
I
nothing.
know the name is super misleading,
Right.
but trust me, null resource is anything but null.
Okay.
It's actually one of Terraform's hidden gems. Think of it as a Swiss Army knife for tasks that aren't directly related to creating or modifying infrastructure.
Wait, so it's not about the infrastructure itself.
Right.
Then what's the point? Give us a real-world scenario where this null resource becomes the hero.
Let's say you've got a complex deployment process.
Yep.
You've got servers coming up, databases being initialized, all sorts of things happening.
Right.
And after a specific server is fully provisioned, you need to run a custom script on it,
Uh-huh.
maybe to install some monitoring tools or set up specific user accounts.
So it's not about creating the server itself, but about what happens after it's up and running.
Exactly. You can't do that directly with a resource like auth_instance. That's where null resource steps in. You attach it to the server resource and say, hey,
Okay.
once this server is ready, run this script.
Okay, I'm starting to see the magic here. It's like adding an extra layer of automation on top of the core infrastructure.
Exactly.
So how does null resource know when the server is actually ready?
That's where the triggers feature comes in.
Oh.
You can set up triggers based on various conditions, like changes to specific files or variables, or even the successful creation of other resources.
Okay.
It's like saying, hey, null resource, keep an eye on this server, and once it hits this specific state,
Gotcha.
go ahead and execute your task.
That is super cool. It's like setting up a chain reaction within your Terraform code. I'm already thinking of a bunch of ways I could use this.
It's one of those things that once you understand it, you start seeing opportunities everywhere.
Okay, let's move on to something that might seem a bit less exciting,
Right.
but trust me, it's just as important. Let's talk about formatting. I'll admit, I've been guilty of writing some pretty messy Terraform code in the past.
We've all been there.
Yeah.
But here's the thing. In the world of Terraform, formatting is about way more than just aesthetics.
Okay.
It's about readability, collaboration, and ultimately sanity.
All right, convince me. Why should I care about making my code look pretty? Does it really matter in the grand scheme of things?
It absolutely matters, especially when you're working on a team.
Okay.
Imagine you're trying to understand a complex piece of code that someone else wrote,
Yeah?
and it's all over the place. Inconsistent indentation, random spacing, no rhyme or reason.
Oh, yeah, I've definitely been there. It's like trying to decipher a message written in hieroglyphics.
Exactly. Now imagine that same code,
Okay.
but it's beautifully formatted
Okay.
with consistent indentation, clear spacing, and logical grouping.
Right.
It's instantly easier to read, understand, and debug.
Okay, I see your point. But
Yeah.
honestly, formatting code manually can feel like a chore. Is there a way to automate this?
Absolutely. That's where the Terraform FMT command comes in.
Okay.
It's like having a personal code stylist for your Terraform files. You run it,
Okay.
and it automatically reformats your code according to Terraform's style guidelines.
So it's like hitting the beautify button on a code editor.
Exactly. And the best part is, Terraform FMT ensures that everyone on the team is using the same formatting style, which makes collaboration a breeze. No more arguing over tabs versus spaces.
I'm sold. Consistent formatting, it's a must.
It really is. It's one of those small things that can make a huge difference in your workflow.
Okay, let's shift gears and talk about those moments when we need to start fresh with a resource. I've heard of something called tainting a resource, but honestly, it sounds a bit aggressive. What's the deal with that?
Think of tainting as telling Terraform,
Okay.
hey, I know you usually try to be efficient and only update what's changed, but this resource, I need you to completely wipe it out and rebuild it from scratch.
Wow, that does sound drastic. When would you ever need to do something like that?
There are a few scenarios where it comes in handy.
Okay.
Imagine you've made some manual changes to a resource outside of Terraform.
Okay. Maybe you tweaked a setting directly in the AWS console or something.
Uh-huh.
Now your Terraform state is out of sync with reality.
Uh-oh. That sounds like a recipe for disaster.
It can be.
Right.
Tainting the resource is like hitting the reset button. It forces Terraform to discard its knowledge of that resource and rebuild it according to your current configuration.
Okay. I see how that could be a lifesaver in a situation like that.
Yeah.
But are there any other situations where you'd use this nuclear option?
Absolutely. Sometimes underlying dependencies change in a way that requires a complete rebuild.
Yeah.
Let's say a service you rely on releases the major update
Okay.
with breaking changes. Tainting allows you to force Terraform to rebuild the resource and incorporate those changes.
So it's like saying, don't try to patch things up, just start fresh.
Exactly.
Yeah.
It's a powerful tool for those situations where a simple update just won't cut it.
All right, we were talking about wiping things clean. Let's talk about actually deleting resources.
Okay.
I know there's Terraform destroy, which
Yep.
seems pretty self-explanatory.
But I've also seen Terraform apply destroy. What's the difference?
It's all about how much confirmation you want before things go poof.
Right.
Terraform destroy is like hitting the big red button.
Okay.
It goes through your entire Terraform state and obliterates every resource it finds.
So use with extreme caution.
Exactly. Now, Terraform apply destroy is a bit more nuanced.
Okay.
It still destroys resources,
Oh.
but it does it as part of the regular Terraform apply workflow.
Gotcha.
That means you get to review the plan
Right.
before anything happens.
Right.
You see exactly what's going to be deleted,
Yeah.
giving you one last chance to back out if you spot any issues.
That sounds a lot safer. Like having a safety net before you jump off the high dive.
It's definitely a best practice, especially when you're dealing with critical infrastructure.
Speaking of safety nets, mistakes happen.
Mm-hmm.
We're human. Let's talk about how to undo those oops moments in Terraform.
Yeah.
What are our options for rolling back changes?
First and foremost, back up your Terraform state file religiously. It's like having a snapshot of your infrastructure at a specific point in time.
Gotcha.
If things go wrong, you can restore a previous state and effectively turn back the clock.
So like a time machine for your infrastructure.
Exactly. But even without a state file backup, you've got options.
Okay.
Version control is your friend here.
Right.
If you've made a mistake in your Terraform code, you can revert to a previous commit and reapply your configuration.
Ah, the good old undo button for our code.
Exactly.
And if we're really in a bind, can we just manually fix things up?
You can, but proceed with caution.
Yeah.
Manually editing resources and then running Terraform plan to see what will happen is a delicate process. It's best reserved for situations where other rollback methods aren't feasible.
Okay. I'm getting the sense that prevention is key here. Having a solid backup strategy
Absolutely.
and using version control diligently can save you a lot of headaches down the road.
Absolutely. And don't forget about testing. The more you test your code, the less likely you are to encounter those oops moments in the first place.
Okay, last but certainly not least, let's talk about modularity.
Okay.
This is one of those concepts that can feel a bit abstract at first.
Yeah.
But I think once you grasp it, it's a total game changer.
It really is. Modules are all about creating reusable building blocks for your infrastructure. Think of it like assembling Legos.
Okay.
You create these self-contained units that you can then use to build larger, more complex structures.
That's a great analogy. I can already see how this could help keep my Terraform code organized and prevent a lot of repetition.
Exactly. And that's where the main.tf, variables.tf, and outputs.tf files come in.
Okay.
These are the essential components of a Terraform module.
All right, break it down for me. What's the purpose of each of these files?
Think of main.tf as the heart of your module. It's where you define the actual resources and their configurations.
Right.
In our Lego analogy, this would be the instructions for building a specific Lego creation. Variables.tf, on the other hand, is where you define the input parameters for your module. This is what makes your modules flexible and reusable.
So it's like having different options for customizing your Lego creation.
Exactly. You can define variables for things like the size of your Lego structure, the colors you want to use, and any other customizable aspects. And finally, outputs.tf defines the values that your module exposes to the outside world. Think of it as the finished product of your Lego creation.
Okay, I'm starting to see how all these pieces fit together, but we're just scratching the surface here.
Right. There's so much more to explore with modules, like using community modules to leverage pre-built functionality, and even creating your own private module registry.
This is definitely a topic we'll have to revisit in another deep dive.
Absolutely.
But for now, I think our listener has a solid foundation to build on. We've covered so much ground already, and I'm excited to keep exploring the world of Terraform.
Me too. It's a constantly evolving ecosystem, and there's always something new to learn and experiment with.
Stay tuned, deep divers. We'll be back soon to dive even deeper into Terraform. Okay, so you've really piqued my curiosity about these modules. Before we went down this rabbit hole of debugging and deleting and formatting, you were explaining how modules help you build awesome infrastructure without repeating yourself.
Yeah.
I think our listener could really use a practical example to visualize this.
You're absolutely right. Examples are key. So let's say you're building out your infrastructure on AWS,
Okay.
and you find yourself deploying the same basic web server setup over and over again. EC2 instance, security group, maybe a load balancer.
That's pretty much the bread and butter of cloud infrastructure these days.
Exactly. Now, instead of copying and pasting that same code block
Okay.
every time you meet a new web server, you can create a Terraform module. Let's call it the simple web server module.
Okay, I'm following so far. So how would you structure this module?
So your main.tf file would be the blueprint for this web server setup. It would contain all the resources, the EC2 instance, the security group with its rules,
Okay.
and even the load balancer configuration if you need it.
So all the nuts and bolts are in main.tf. What about variables.tf? How does that come into play?
That's where the magic of reusability happens. In variables.tf, you define things like the AMI ID for your web server, the base image it's built from, the instance type, the port for web traffic, maybe even the allowed IP ranges for your security group.
So instead of hard coding all those values, you're making them customizable.
Exactly. That way, anyone using this simple web server module can tweak these variables to fit their specific needs. They might need a different AMI for a specific application, or maybe they need a beefier instance type for a high-traffic website.
And what about outputs.tf? What kind of information would you want this module to output?
Great question. For a web server module, you definitely want the public IP address of the EC2 instance.
Right.
That's how other parts of your infrastructure or even external users would access the website, right?
Yeah.
You might also output the DNS name of the load balancer if you're using one.
So it's like providing a handy reference guide for anyone using the module. Here's how to connect to what you just built.
Exactly. And once you have this simple web server module, you can use it anywhere in your Terraform code.
Okay.
Just call it up, set the variables you need, and boom, you've got a fully functional web server without writing all that code again.
That's seriously cool. I can already see how this would save me tons of time and keep my code so much cleaner.
Yeah.
Talk about working smarter, not harder.
That's the beauty of modularity. And as you start building more complex infrastructure, you can create modules for all sorts of things. Databases, networking components, even entire application stacks.
It's like having a library of pre-built infrastructure components ready to go. I'm definitely going to be experimenting with modules after this deep dive.
Awesome.
Okay, let's shift gears back to debugging for a moment.
Yeah.
Earlier, we talked about using Terraform Validate to catch syntax errors.
Right.
But what if the problem is more than just a misplaced bracket or a typo?
Yeah.
What are some strategies for tackling those trickier debugging challenges?
Those can be frustrating for sure, but there are definitely ways to unravel the mystery.
Okay.
First off, don't panic. Take a deep breath and look closely at the error message.
Okay.
Often it'll point you to the specific resource or module where issue is happening.
Okay, so it's like having a starting point for our investigation.
Exactly. Then it's all about breaking down the problem into smaller, manageable pieces. Focus on that specific resource or module and examine its configuration with a fine-tooth comb.
So kind of like a detective gathering clues at a crime scene.
You got it. Double-check every variable value, look for any inconsistencies, and try to understand the logic of that piece of code. Sometimes the issue might be in a completely different part of your code that's affecting this resource indirectly.
Oh, that's happened to me before. It can be so frustrating when you're staring at the wrong section of code the whole time.
It's all part of the debugging journey. And if you're using modules, try testing that specific module in isolation to rule out any problems within the module itself.
Good tip. Isolate the suspect, see if it acts up on its own.
Precisely. And remember, you're not alone in this debugging adventure.
Right.
The Terraform community is incredibly helpful, and chances are someone out there has encountered a similar issue before.
Right.
Don't be afraid to reach out for help.
That's a great point. There are some amazing forums and online communities dedicated to Terraform.
Absolutely.
Okay, speaking of the community, it's also a fantastic resource for finding pre-built modules, right?
Absolutely. There are tons of open source modules available for all sorts of common use cases. Why reinvent the wheel when someone else has already done the heavy lifting?
That's a great point, especially when you're starting out with Terraform.
For sure.
Using community modules can be a huge time saver.
Right. And often, these community modules are well maintained and follow best practices, so you can be more confident in their quality and security.
But I imagine there are still some things to keep in mind when using someone else's module, right? I wouldn't just blindly copy and paste it into my code.
That's wise. Always take the time to review any module thoroughly before incorporating it into your own code.
Right.
Make sure you understand exactly what it does, how it works, and whether it aligns with your specific requirements and security standards.
So it's like doing a background check on the module before you invite it into your infrastructure.
Exactly. You want to be sure it's a good fit.
Right.
And that you're not introducing any vulnerabilities or unexpected behaviors.
Okay. I'm taking notes. Review, understand,
Yeah.
then integrate.
Yeah.
Now let's talk about a scenario that can sometimes throw a wrench into our Terraform plans. Those pesky resources that exist outside of Terraform's control.
Right.
I'm talking about things that were created manually or through some other tool. How do we manage those external resources in our Terraform code?
That's where data sources come in.
Okay.
Data sources are like Terraform's way of peering into the outside world and gathering information about existing resources.
So it's like giving Terraform a pair of glasses to see those resources that are already out there.
Exactly. For instance, let's say you have a VPC, a virtual private cloud on AWS.
Okay.
That was created manually before you started using Terraform. You don't want to recreate it with Terraform.
Right.
But you do need to reference it in your code.
So it's like saying, hey, Terraform, I need to work with this VPC, but I didn't create it with you. Can you just get me the information about it so we can play nicely together?
Precisely. You'd use a data source to fetch all the details about that VPC, its ID, its CIDR block, any subnets it has, and so on.
And then Terraform can use that information to configure other resources that depend on the VPC.
Exactly. Once you have a data source for an external resource, you can reference its attributes in your Terraform code, just like any other resource. It's a powerful way to integrate Terraform with your existing infrastructure.
Okay. I'm starting to see how data sources can bridge that gap between the Terraform world and the pre-existing world.
Yeah.
Now, let's dive into something that I think a lot of people find a bit mysterious: state management.
Okay.
You mentioned the Terraform state file earlier,
right?
But I think it deserves its own spotlight. What exactly is this state file, and why is it so crucial to the whole Terraform ecosystem?
Imagine the Terraform state file as the brain of your infrastructure as code.
Okay.
It's the central repository of knowledge about everything Terraform has created. It knows what resources exist, their current configurations, their dependencies on each other, all of it.
So it's like a master inventory for our entire infrastructure.
You got it. This state file is absolutely crucial for Terraform to function correctly. When you run Terraform apply, it compares your code to the current state and figures out exactly what needs to be changed, added, or removed to make your infrastructure match your desired configuration. Without the state file, Terraform would be flying blind.
I can see how that would be disastrous, like trying to renovate a house without a blueprint. We talked earlier about backing up the state file for rollback purposes.
Right.
But are there any other best practices for managing this all-important file?
Yeah.
Especially when you're working on a team.
That's a great question. And team collaboration is where state management gets really interesting. When you're working with multiple people, it's vital to have a centralized and secure location for storing your Terraform state file.
Right.
That's where backends like Amazon S3 or Terraform Cloud come into play.
So it's not just about backing up the file, it's about having a shared source of truth for the entire team.
Exactly. Using a remote backend allows everyone on the team to access the same state file, ensuring that everyone is working with a consistent view of the infrastructure.
That makes a lot of sense. I can imagine it would be chaos if everyone was working with their own local copy of the state file.
It would be a nightmare, for sure. A remote backend also brings other benefits, like state locking. That prevents multiple people from making changes to the state file at the same time, avoiding all sorts of conflicts and potential overwrites.
So it's like having a traffic light system for our infrastructure code. Only one person can make changes at a time.
Exactly. It's all about maintaining order and consistency, especially when you've got a whole team working on the same infrastructure.
This is gold. State management, remote backend, state locking, it's all starting to click. I think this is a good place to pause and let our listener absorb all this goodness before we move on to the final leg of our Terraform journey.
Sounds like a plan. We'll be back soon to explore some more advanced concepts and wrap up this epic deep dive.
Welcome back, deep divers. We've covered so much ground already, from the building blocks of Terraform to the intricacies of state management. I feel like we're starting to see the bigger picture
For sure.
of how Terraform works its magic.
It's all about connecting those dots.
Mhm.
And we still got some exciting pieces of the puzzle to explore.
All right, hit me with it. What else do we need in our Terraform toolkit?
Let's talk about something that's essential in any real-world deployment. Handling sensitive information securely. I'm talking about
Oh.
API keys, database passwords,
Okay.
those kinds of things that you definitely don't want floating around in plain text within your code.
Oh, yeah. Security is paramount. Hard coding secrets into our Terraform code is like leaving the keys to our kingdom out in the open.
Exactly. It's a recipe for disaster.
Good.
Fortunately, Terraform gives us several ways to manage secrets safely. One common approach is to use environment variables.
Okay.
You store your secrets and environment variables on your local machine or build server,
Okay.
and then reference those variables in your Terraform code.
So it's like keeping those secrets tucked away in a separate vault, only accessible with the right credentials.
Precisely. And if you're working with a cloud provider,
Right.
you can leverage their secret management services. For example, AWS has Secrets Manager, a service specifically designed for securely storing and retrieving sensitive data.
Right.
You can integrate that directly into your Terraform code.
That sounds much more secure than having those secrets embedded in our code.
Yeah.
Out of sight, out of mind, but still accessible when Terraform needs them.
Exactly. And it's important to remember that security is an ongoing process. It's not a one-time setup.
Right.
Regularly audit your secrets, rotate them as needed, and stay up to date on best practices for secure secret management.
Great advice. Now let's dive into a concept that can be a bit tricky to wrap your head around at first: implicit and explicit dependencies.
Right.
What are these dependencies all about, and why should we care about them in our Terraform code?
Dependencies are all about the order of operations. Sometimes you need one resource to be fully created and configured before another resource can even start. It's like building a house. You need the foundation in place before you can put up the walls.
Okay, that makes sense. So how do we tell Terraform about these dependencies?
There are two main ways:
Okay.
explicit and implicit dependencies. With explicit dependencies,
Okay.
you're literally telling Terraform, hey, make sure resource A is ready to go before you even think about touching resource B.
Okay.
You do this using the depends on meta argument.
So it's like giving Terraform a checklist. Do this first, then do that.
Exactly. But here's the cool part. Terraform is also smart enough to figure out some dependencies on its own.
Oh.
It looks at how your resources are configured
Oh.
and can often deduce that, for example, a web server needs a network interface before it can be launched. These are called implicit dependencies.
So it's like Terraform is doing some detective work behind the scenes, figuring out the logical order of things
Precisely.
based on how we've defined our resources.
And understanding both implicit and explicit dependencies
Okay.
is crucial for ensuring that your infrastructure is built in the correct order. It can prevent all sorts of errors and headaches down the road.
Okay, I'm starting to appreciate the importance of dependencies. It's like a carefully choreographed dance, making sure everything happens in the right sequence.
Exactly.
Now, let's wrap up our deep dive with a topic that's close to my heart.
Yeah.
Testing.
Okay.
We've talked about using Terraform Plan as a sort of preview,
Right.
but how can we go beyond that and really make sure our infrastructure is going to work as expected?
Testing is essential for any kind of code, and infrastructure as code is no exception.
Right.
In fact, it's even more important because we're dealing with real-world resources that can have a significant impact if things go wrong.
Absolutely. So what are the different levels of testing we can implement with Terraform?
At the most basic level, you have unit testing, where you focus on testing individual modules or resources in isolation. You're making sure each piece works correctly on its own.
So it's like testing each ingredient before we bake the cake.
Exactly. Then you have integration testing,
Okay.
where you test how different modules or components of your infrastructure interact with each other.
Right.
You're making sure the pieces work together harmoniously.
And finally, we have end-to-end testing, right?
Right. This is the most comprehensive type of testing,
Oh.
where you deploy your entire infrastructure stack and run tests that simulate real-world usage.
Okay.
You're verifying that the whole system functions correctly from start to finish.
Okay, that sounds pretty intense. Are there any tools or frameworks that can help us with these different levels of testing?
Absolutely. There are some amazing tools specifically designed for testing Terraform code. TerraTest is a popular one.
Okay.
And there's also Kitchen Terraform and Inspec.
Okay.
These tools provide frameworks and libraries for writing automated tests, making it easier to build reliable and robust infrastructure.
Wow. This deep dive has been an incredible journey. We've covered so much ground from the basics
For sure.
to some seriously powerful techniques. I feel like I've leveled up my Terraform game significantly.
That's the power of knowledge. And remember, Terraform is constantly evolving. Embrace the learning journey, experiment with what you've learned, and never stop exploring.
And who knows? Maybe you'll discover some tips and tricks of your own to share with the Terraform community. Until next time, deep divers.